Hey everyone, and welcome to this crash course on Arduino with OOP, or Object-Oriented Programming. If you want to write clean and scalable Arduino code, or if you want to create nice and easy to use Arduino libraries, then using OOP is really a great start. In this crash course, we will write a complete class for an LED. I will explain not only how to create the class and use it in your code, but also how to clearly organize your code so that you can create a clean and structured library. Don't worry if you don't know much about OOP, you will be able to understand the main concepts in an intuitive way when writing the code. Also, if you want to go further, I have actually a much bigger course on Arduino and OOP, which covers a lot more than this. You can find the link in the description below. Alright, and now let's get started and let's create a class for an LED. What we are going to do to create the class is to actually rewrite the blink LED example. This example is super simple and common, so we will be able to focus 100% on the OOP code. Writing the class with this example in mind will help us find what functionalities we need to implement. So as you can see on this code, first we define a pin, okay, we've defined LED pin 13. Then in the setup we use pin mode to set the pin mode as output, so we can then write to that pin. And in the loop function, we use digital write with high to power on the LED and digital write with low to power off the LED, okay, and that's it. So that's a very simple example. One important thing here is that when writing Arduino code with OOP, we will always do it with a functionality in mind or a goal to reach. This is super important. Writing classes is not just about writing classes for the sake of it. This is a process to help you reach the goal you want with your application, just using a different way than the traditional one. So now, before we write the class, we need to think about what we need to do. So what do we want here? We want to make the LED blink. That's our goal. What attributes do we need then for the LED? So we need to keep track of the pin for the LED so we can use it in our program. And what functionalities do we need to implement in order to make the LED blink? Well, as you could see in the blink example, we first need to initialize the mode for the pin, and then we need the functionality to power on or to turn on the LED, and another functionality to turn off the LED. And so those attributes or properties that are going to define the LED and the functionalities, we are going to put them in a class, and that's the class we are going to create. And well, that's pretty much it for now. One attribute, 3 functionalities. Let's now start writing the LED class. And let's start by writing our first class, and this class is the LED class, and you can see here we have the blink LED example, which we are going to rewrite using object-oriented programming. So I'm going to create a class here on top of the void setup and void loop, and to create a class, first I need to use the class keyword. So the class keyword here should turn blue, as you can see. And then just after the class keyword, I can specify the name of the class. So I'm going to name it LED. And a very important convention is to start the name of the class with an uppercase letter, okay? So you start with an uppercase letter, and then, well, this is an LED, so I could write, for example, like this, class LED with all uppercase letters. What I'm going to choose instead is to use lowercase for E and D. Okay, so I can just keep the uppercase here, and that doesn't really make any difference. So once you have class and the name of the class, you can open and close curly brackets. Let's actually put this in a new line, and everything between those two curly brackets is related to the class LED. So every new attribute, every new functionality you want for this class, you are going to put it inside this block of code. And one very important thing is that after the closing curly brackets, you are going to add a semicolon. Very important, otherwise you will get a lot of errors in your code. So this is the structure of the class. Class keyword, name of the class with an uppercase letter first, curly brackets, semicolon. And now in this class you will be able to write all the functionalities, so we can use what we call abstraction, which means that you're going to abstract all the functionalities here, the pin mode, digital write, etc. So in your code you just need to call different functions and methods inside the LED class, and you don't need to worry about using pin mode and digital write directly in the code of the setup and the loop. Okay, and once you have created the structure for the class like this, we can start to add attributes and methods. And here we are going to focus on the attributes. So actually, what kind of attribute we need for the LED? We just need one, which is the pin. Okay, so we will need to store the pin number for the LED. So then in the class, we can use that pin number from the different functions we implement. And before I actually declare the pin for the LED, I'm going to add private like this. So private colon and then public colon. And this is an important concept of object-oriented programming. So basically, everything that is below private here will only be available from within the class. Okay, and anything below public will be available from outside of the class. So you are going to understand fully with an example when we actually create an object, okay, and we call the different functionalities of the class. Basically, so if you create an object here, an object from the class LED, and you try to call something that is declared here after private, then it's not going to work. You will only be able to call, so to get the attributes and to call the methods after the public keyword. So everything in private will be accessible from the method you write in private and in public inside the class only. And this is called encapsulation. Basically, you create some variables and functions that you protect inside the class so they can't be modified from outside the class. And here I'm going to add a private attribute, byte pin. So byte is actually an Arduino specific type, okay? And then I name it pin. So as you can see here, previously I have defined LED pin for the global code like this. Here I don't need to say LED pin because the pin is actually inside the LED class. So writing LED pin here would be quite redundant, okay? Because we already know this is the LED pin because this is inside the LED class. So here, well, that's pretty much it. We have all the attributes we need, which is basically just one attribute. So for each attribute you want to add to the class, you are going to add the data type and then the name, semicolon. So you just declare each attribute here line by line. And usually the best practice is to put the attributes below the private keyword. And the private keyword, as you can see here, I didn't put any indentation. You can just put it to the indentation 0. That's not a problem here. Okay, so that's how you declare your attributes for the class and how you encapsulate them inside the class with the private keyword. Great, so now we have a class with some private attributes. The next thing we are going to do, and this is an important thing that you have to do for any class you create, is to actually define a class constructor. And the class constructor is actually a method. So when I say method, basically a method is a function inside a class, okay? That is simply a different name. So a class constructor is basically a public method you are going to put here. And the name of the constructor is the name of the class, okay? It should be the exact same name. And it doesn't have any data type here. So there is no void, there is no int, long, anything. You just create the constructor like this, name of the class, okay? And then the parameters, so you can have some parameters, let's say byte pin, and then you can implement the function or the method. And this constructor is actually what will get called when you create an instance of the class. So this is where basically you initialize the class, okay? Because the class by itself is nothing, it's just a kind of a structure. When you create an object from the class, this is going to be called. So here, of course, to initialize the class, I'm asking for the pin number for the LED. And so I can put this inside the private attribute that we have here. And to do this, I could do pin is equal to pin, but problem is here we have pin from the class and pin from the parameter. So that's not going to work because pin here is not actually the one from the class. Pin will be the one from the parameter. So that's simply going to put the value from the pin parameter inside the pin parameter. To solve this, we can do this and then an arrow. So the keyword this, arrow, pin, this means that we are going to use, so this refers to the class. So this is the pin attribute we have here. And this is the parameter. So what we do in this constructor is very simple. We just initialize the attribute we have in the class. So now the pin number is stored inside the class and we can use it in other functions. And coming back to the encapsulation with the private keyword, here you can see so pin is private, but we can actually directly use it. We can get it and we can set it inside the class. So here we are inside the class. This is a public method. We are going to use the pin attribute here. This is possible. If you try to get direct access to this outside of the class, it's not going to work. The only option you have to change the pin is to create a class and call this constructor. Okay, and one other thing here for the pin number, well, there are different conventions for object-oriented programming. The one I'm going to follow is simply to start with lowercase, so just use them like normal variables. Another convention you could do is to start any attribute from the class, any private attribute, with a leading underscore. Okay, in this case, I'm going to comment this. In this case, for example, this and this are different. So you could do underscore pin is equal to pin. So as long as there is no new parameter or new variable that kind of overrides the attribute, well, you can directly call the attribute like this. And using an underscore here at the beginning, you can make sure that the name here of the attribute will always be different from the names of the variables you use in the program of the class. So this is an option. Another option, well, you might see stuff like this, like member, M for member. Well, there are many different options to write attributes. I'm just going to stick with maybe the most standard one, okay, which is simply to write the attribute like a variable. And then when you need to get the attribute, you simply write the variable. And if you have a conflict of name like this, you use this. So this line makes it very clear what we are going to do. And well, that's it for the constructor. With this, we will be able to create an LED object and assign a pin number here to the class. And finally, one important thing I'm going to add is add what we call a default constructor. So here the constructor has one parameter. A default constructor has 0 parameter. So for some classes, you may not need any parameter actually. So you could just create the default constructor like this. For the LED class, it makes sense to ask for the pin number, okay? Because if we don't know the pin number, well, we can't do anything with the LED. But because we create a different constructor, we are going to add also a default one and simply define it like this. And we don't write any code inside this. And maybe add a comment, do not use. And the simple reason why I'm doing this is because if you don't add a constructor like this, a default constructor, then later on in your programs, you may have some compilation errors. And I'm going to come back to the compilations error when we have the problem actually. So basically what you need to do, you create a default constructor every time. And well, in this case, we are not going to use it. So I just had here like a comment say do not use. A common thing to do in C++ is if you want to write a default constructor that you are not going to use, you can simply throw an exception here. But with Arduino, you can't use exceptions. So, well, I'm not going to make a very complicated thing here to handle the default constructor. Simply write an empty one and do not use. Alright, and now we have the attributes and we have the constructor for the class. And last note here, as you can see, you can add as many constructors as you want. You just need to provide different parameters. This is called function overloading. Okay, so you create different functions with different prototype here, which means that different number and types of parameters. So you give more options, okay, for the same function, you can have different number of parameters. And now the last thing we need to do for the class is to add the methods of the class. So we have the attributes, okay, which defines basically what is the class. Then we have the constructor here, so we can create an object, but then we need to add the methods to implement the functionalities of the class. So basically, what do we want to do with this class? So we want to do actually three things. We want to be able to initialize the LED. So I'm going to create a void init function. Okay, so the prototype and actually the definition of the function. We want to be able to power on the LED. So I'm simply going to call this method on. Okay, it makes sense inside the LED class. Okay, if you call LED.on, you know you are going to power on the LED. If this was outside of the class, you would need to call it power on LED to make sure that you know what it is. Okay, because this is inside the class, then you have some more context. And you need void off also. What are we going to do in the init function? Well, we are going to call pin mode with the pin number, so pin. Here, we use the pin attributes that we have and that we got from the constructor, and then output. Because this is an LED, we are going to set it as output. And then to power on the LED, we simply do digital write with the pin number and high. And to power off the LED, digital write with the pin number and low. And well, that's pretty much it for the implementation of the methods of the LED class for now for what we want to do. So as you can see, we use abstraction. So instead of now, if you want to power on the LED, instead of calling digital write with the pin and high, we are just going to call LED on, which makes more sense, okay, with the context. And one last thing I'm going to do, actually I'm going to create another void init function. So I'm going to create an overload of this method by default state. So let's say you want to set a default state. So you want to initialize with pin mode and you want to set a default state. With just init, well, it's initialized to output and the default will be low. Now you may want to specify directly low or high. And in this case, instead of calling init without any parameter, you may call init with a byte parameter, which will be high or low. And in this case, what I'm going to do, I'm going to call the init function first. And then I'm going to do if default state is equal with 2 equal to high, then I'm going to do on, and else I'm going to do off. And here you can see that we don't repeat code, okay? So the pin mode function inside the init, we're not going to repeat it here. Instead, we just call the init function, okay? And here, if the default state is high, then we just call the on function. We don't just write digital write again. Okay, so that is very powerful with object-oriented programming, is that you create some methods and then from any method inside the class, you can also call the other method of the class. So you can really build more complex functionalities that actually make sense. All right, and now the class here is finished. And now that we have our class ready to be used, well, let's use it. So here, what I'm going to do, I'm going to replace that with the functionalities of the class. And the first thing I need to do is actually to create an object. So when you have a class, this class is just, well, this is just a structure, okay? This doesn't do anything by itself. What you need to do is to create an object, which is an instance of the class, and then you can use the class. So to create an object, it's very simple. First, you put the name of the class, so LED, and then the name of the object you want, which can be anything. I'm just going to call it LED with lowercase. And then, so if you are going to use the default constructor, which is no parameter, in that case, you just put a semicolon. And that's it. The default constructor will be called. Now, if you want to use another constructor, actually we want to use that one, then you add some parentheses. And then you provide the parameters here. So we need to provide the pin number. And we have a defined LED pin, so let's actually use that define right here. So this line, what it will do, it will call the constructor here. So we provide an LED pin, which is a byte. It will call the LED here constructor and assign the pin number we give, okay, to the pin here, the private attribute from the class. And note that here I have created the object in the global scope. Okay, so that's what we are going to do here in this course. We are going to create objects here in the global scope so we can use them in the setup and in the loop function. So now that we have our object, well, we need to use here, I'm going to replace this with led.init. So as you can see here, there is no more pin mode, etc. The pin mode is inside the class. So I could use init or init with default state. I just use the normal init. One thing that you may want to do is to actually do the init inside the constructor, but this is not really recommended because, well, when you create here a variable with the constructor, you don't necessarily know which order the constructor is going to be called, when exactly. So it's better to initialize hardware components in the setup. So like we did before with the pin mode, here we just call the LED init inside the void setup of the Arduino program. And now in the void loop function, what we want to do is not digital write LED pin high, we just want to do LED.on and then LED.off. So yeah, as you can see, to call a method from an object, you just add dot. Object.method. And the method should of course be public. If it is private, you will get an error because you can't call a private attribute or a private method. Here, all the methods we have created are public, so we can call them from the code here directly when we create an object. And well, you can see that this code here, when you look at this, just this is much more clear. And you have much more context and much more abstraction. Here it is very clear that we create an object, so an LED, we provide a pin number of course, and then we initialize the LED, and then we power on the LED. So we wait with a delay here, and we power off the LED. This makes much more sense than writing digital write, because what does digital write means? Digital write means that you are going to use some hardware functionalities from the Arduino to write some value, some digital value to a digital pin. It doesn't mean you are going to power on an LED, okay? So with this, we have much more context. And as you can see, all the Arduino functionalities here are inside the LED class. So basically, it's like they are hidden. So when you just see the main program, you don't see the hardware functionalities, you just see the context and the abstractions that you use. And well, for now, as you can see, the code is, well, much more bigger than the code to just make an LED blink. But this is just because this is the setup for the project. And later on, just after that, we are going to see how you can better organize your code so you can reduce the main code. And then when we are going to add more functionalities, more classes, etc., you will see the true power of object-oriented programming. And your code, instead of just getting bigger and bigger and bigger, will get much more organized, scalable, modular, readable, etc. And one last thing here is when you actually create an object, well, you can directly create an object like this, or you could try to use dynamic allocation with the new keyword, for example, and the delete keyword, but that's not really recommended in Arduino because, well, Arduino is quite limited, and if you have a small program like this, well, you don't need dynamic allocation. And if you have a more complex program, maybe using dynamic allocations, you will have problems with the memory and, well, you are going to mess things up. So I recommend using this way to create objects, which is to directly call the class object constructor with the parameters in the global scope. And well, actually what we can do, of course, is so let's compile the code. Let's name it LED OOP. Okay, so it's done compiling, and then we can upload the code. So make sure you have correctly set the board and the port right on tools, and we can upload the code to the Arduino. And you can see here the built-in LED, so the LED with the pin number 13 that we are using is actually blinking every 500 milliseconds. So, well, the functionality here is working correctly. And congratulations, because you have written your first class with Arduino. And now, if you like this tutorial so far, and if you want to go further with Arduino and OOP, well, I have a complete course on this topic, which contains more than 4 hours of video content. Check out the link in the description to know more about it, and now back to the video. Great, you now have a first class that you can use to power on and power off an LED. And before we go any further, there is an important thing we need to do if we want to keep our programs and projects clean, easily readable, and to easily be able to modify them. In the following lessons, you are going to organize your code and files to correctly work with your class. And the main thing we are going to do is to separate the interface from the implementation, and also to move the LED class outside of the main program. Okay, so how we are going to do this? As you can see here, our main program, so this is what we have built for now. We have the LED class, okay, and then we have the void loop and the void setup. So that's our program for now. What we are going to do is we're going to remove completely the class from the main program. We are going to create a new file, a header file, so .h file, and this is going to be what we call the interface. So the header file will contain the attributes, so declare the attributes, for example the pin, and it will also contain the declaration of all the methods we are going to use. Note here it's only the declaration, so basically the prototypes for the function. And then we are going to create a .cpp file, which this file will contain the implementation. And this file will implement the code inside the different method of the class. So you will have the implementation with all the code and the logic and everything, and you will have the interface file, which just contains, well, the interface. It just contains the information you need to be able to use the class. And from that, we are going to include the LED header file from the main program. So we can use the LED class from the main program in the void loop, in the void setup. Alright, so 3 steps here: create a header file, and then create an implementation file, and then include the header file or the interface in our main program. And well, let's get started. Alright, let's now start to organize our code with the LED class. So for now, as you have seen, we have the LED class defined here, and then we create the LED object, and then we have the setup and the loop function. What I'm going to do first is to create a header file. To create a header file, well, basically we need to create a new file on our project. And to do this, well, there is a button here. You can click on this button, and you click on New tab. And you can see on the bottom here, you have name for new file, and you can choose a name. And I'm going to name it LED, just like the class here. So the same name, .h, and then click on OK. And you have a new file, led.h. And now the very first thing we are going to do for any header file we create, and this is very important, you should do that for every header file, is to create what we call define guards. So let me create one and let me explain to you. So you do if and def, so basically if not define, okay, like this, if and def, and then let's put the name led_h, define led_h, so if this is not defined, we define it, and then we add endif. And everything we are going to write in this file will be between the define and the endif. And this is basically why we do this, is when we are going to include that file from other files. All the content here will be written on the other file. So basically, if we have two different files that call the led.h, we will have a duplication of the code. So the class will be duplicated everywhere. By using the header guards like this, we make sure that the class will be written only once in the program. Okay, so if and def, and then define, and then endif. So well, you just need to remember you have to use this structure for any header file you create. And for the define, what you can use is simply the name of the file. Okay, so here the name of the file is led, and then _h, all uppercase. So that's also a convention that you can follow. All right, and now I can write the code inside this, okay, between the define and endif. So I'm going to go here and just take the entire class. I'm going to cut and paste it here like this. So now on the main file we have nothing. Okay, and if we try to compile like this, of course that's not going to work. And in the header file, so here we have the led class, okay, between the define and the endif. One important thing you need to add also, specific to Arduino and when you create other files than the main file, is if you are going to use the Arduino functionalities, so for example pin mode, digital write here, or millis or whatever, you need to also include, so again, after the define led_h, everything will be after this, you need to include the Arduino library, so Arduino with the angle brackets, Arduino.h. And I'm going to show you later the error that you are going to get if you don't include that, okay? Because there is no magic. If you want to use the Arduino functionalities, you need the Arduino library. And where the magic is actually with the Arduino IDE is that from the main program that you have here, this line is automatically added for you. So that's why you don't need to include Arduino in your main program. But when you add a new file, this line will not be added for you. So you have to add it by yourself. And now if I try to compile, let's actually save as, let's say Led OOP with organized. Okay, so I save it. And now let's verify the code. And we get an error, of course. And the error is here because LED does not name a type. Because, well, you have the LED class, which is in a different file, but, well, you don't include that file. So what you need to do here is do include. And then to include a file, you are going to use quotes. You are not going to use angle brackets. If you include a file from your folder here, you use quotes, led.h. So that is the name of the file. When you include led.h, it's going to include the class LED. So now it's just like you have written the class here on top of the program. And now I verify again, and it's working. So as you can see, first step, we have removed the class from the main program, and now the main program is actually much shorter, which is of course better. And one thing about this new file, okay, if you want to remove it or rename it or whatever, well, so you can create a new file like this, new tab. You can also rename, okay, and if you click on delete, it's going to remove the file. So great, we have now removed the LED class from the main program, and it is now on a different file. But we didn't actually separate the interface from the implementation. Okay, because the interface is what? The interface is basically the name of the attributes, the name of the functions, and the implementation is what is inside the function. And here we are mixing everything. So the interface and the implementations are on the same file. So to separate this, I'm going to create a new file here, so new tab, and I'm going to name it LED, so the same name, exact same name as here, but instead of .h, I'm going to use .cpp because we are using C++. So this file will be linked to that one, okay? The two of them are going to work together. This one for the interface, this one for the implementation. The first thing you are going to do in that cpp file is to include the header file. So include led.h with quotes. Okay, so as you can see now we have include led.h here and include led.h here. Okay, and this is where the header guards will be very useful. Okay, and now I'm going to transfer the implementation here from this file to the cpp file. And to do that, I'm simply going to, I'm going to select all the functions here. All right, I'm just going to keep the default constructor like this. So I copy this and I paste this here. Okay, let's do a little bit of cleaning. So I'm going to select everything again and do Shift Tab to remove the indentation. And now I have the implementation on my cpp file. But this is not enough. So what I need to do in the implementation file is actually to add the name of the class before any function. Okay, so I'm going to add the name of the class, led, and then colon. Okay, this I need to add it before any function. So for the constructor, just like this. For any other function, so you have the data type first, and then the name of the class, colon, and the name of the function and the parameters. The name of the method, sorry. Because this means that you are going to implement this method from that class. Okay, this is like a namespace that you add. So I need to add it everywhere. Here and then here, and now you have the correct CPP file. And what I can do now in my header file is to remove the implementation. Just leave the declaration or the function prototypes. So here it's very simple. I remove all of that with the curly brackets, and instead I just put a semicolon. I do the same for init, semicolon, this init also, and the on and the off. Okay, and then I can group the methods like this. And now you have separated the interface from the implementations. So the implementation here, all the logic, okay, from all the functions that you have declared here. And the interface, as you can see now, is very small. We have just 21 lines of code, and the class is very small here, okay? And just with this, you can see, you can have a clear overview of what is the class about. You have a pin here as a private attribute, and then you have two different constructors, one you should not use, two different ways to initialize the LED, and then a function to turn off, and a function to turn on the LED. So let's see if that compiles. Okay, and now I'm going to show you different errors that you may have. So let's say I don't include the Arduino.h here. Let's verify the code. And we have a problem because, what does it say here? It says byte does not name a type. Because if you remember, I told you that byte is actually a type specific to Arduino. This is not a standard C++ or C type. So the problem here is because you don't include the Arduino library, byte is not recognized. So you need to include Arduino.h. Now, another error you may have, let's say you forget to add this. You forget to add the class with the colon. So this happens a lot actually, even for myself. I often forget from time to time this, and then you will get the error, which is here, as you can see, in function void init, so pin was not declared in this scope. So basically, this error is not a super explicit error, but it says that the pin is not declared because basically you don't have access to any pin variable. Okay, the pin variable doesn't exist in the program. We just have the pin attribute inside the class LED, but we don't have a variable called pin. And this is because simply this function is out of the namespace, is out of the class. So you may have all kinds of strange errors, okay? And when you have an error like this, first make sure you have correctly put the name of the class, okay, with this. So this is in the class, kind of in the class namespace, and now it's working. All right, and that's the end of this YouTube crash course. I hope you learned a lot, and if you want to go further, I have a complete course for you on Arduino and OOP. So in the course, you will also create classes for a push button, a potentiometer, a traffic light system, etc, etc. We will go much further than this. So here is basically what we have in the course. So we have an introduction with more explanations about why OOP for Arduino, and then, well, you have the first Arduino class with the LED, which is the one we did in this crash course. And then how to organize the class in a clear way, and actually we also did the beginning of that section, but in the course you also have how to make your class an Arduino library, so how to correctly package your class into an Arduino library that you can easily reuse. We will then build a circuit for the course with some push buttons and potentiometer. And then we will create a complete new class for a push button. After that, we will go further and create a class to use a functionality on top of an LED, for example here to make an LED blink directly inside a class. And then we will create a complete traffic light system using all of the components and all of the functionalities with different classes working with each other. So at the end of the course, you will be able to write a class for any Arduino functionality and rewrite your own projects using OOP. Alright, thank you for watching, see you in the course or in the next tutorial.